Hi everyone, I'm Nazarii Hryhorash. I work with Yurii Kryvenchuk, and today I'm going to present you our research about forecasting demand for food delivery services. Um, so what is it about? This article is about investigation of different algorithms for forecasting demand for food delivery services. Uh, why is there a need for this research? Um, as we enter the digital area, how we live and buy things is changing very fast. More and more people are choosing order food online instead of going to the cafe or restaurants. This is because it's more easy, the service is better, and because our experience with COVID-19. Uh, this situation in the food delivery service industry presents both opportunities and challenges. While the sector is booming with potential efficiency managing and prediction, the demand is becoming a critical issue for restaurants and food delivery platforms. Accurate demand forecasting can save resources, reduce food waste, improve customer satisfaction with timely deliveries and proper management, and eventually increase the overall profit margins. Um, Inaccurate forecasting can lead to overstocking or understocking, which in turn can lead to food wastage and bad experience at all. So, what is our key idea? Actually, in our research, we focus on identifying and understanding the most applicable prediction algorithms that can effectively forecast the demand for food delivery services in our world. We are not developing new algorithms, but we might be exploring and evaluating existing ones, such as linear regression, LASSO, decision trees, random forest, and gradient boosting. Um, so let's speak a little about methods analysis. Um, Linear regression. Uh, so linear regression analysis is a helpful statistic tool used to forecast a dependent variable by looking at one or more dependent variables. It works by creating a straight line that shows the relationships between the variables. Um, Linear regression will use the data to establish uh, linear relationships between the dependent and independent variables. Using those relationships, it predicts the value of the dependent variable. However, this method has its limitations. It assumes that changes in the dependent variables can be fully explained by changes in the independent variables, which may not be true in the real world. Next one is least absolute shrinkage and selection operator. Analysis is actually an extended version of regression used in statistical modeling. It's great for prediction patterns and making precise forecast by setting some regressions coefficients to 0. The main goal is to pick the best model and keep it in check, which boosts how accurately we can predict and understand the statistic model it creates, especially when we work with lots of data. Um, Next one is gradient boosting. Gradient boosting is a method that creates a series of simple models, one after another, refining predictions by paying attention to where our models made mistakes. It's really good at dealing with different types of data and finding complicated patterns by adjusting a function to reduce errors bit by bit. Even though it needs a lot of computing power and can sometimes fit too closely to the training data, so it has big risk to overfitting. In the context of predicting demand for delivery services, um, these simple models can be built on the basis of various attributes such as distance from a restaurant, to restaurant rating, price, order time, city, and so on. Each new model improves the existing whole model by minimizing prediction error. Next one is decision trees. Decision tree analysis is a graphical representation of possible solutions to a decision based on certain conditions. It's a supervised machine learning technique used both for classification and regression problems. The tree consists of nodes representing the attributes of features, branches symbolizing the decision rules, and leaf nodes indicates the outcome or actual decision. It enables users to address complex problems by breaking them down into smaller, more manageable parts by visually mapping. So in the case of food delivery service, the attributes that can be included in a decision tree can include decision delivery cost, delivery distance, ratings, and many others features. Random forest. Actual random forest analysis is a technique that works by building lots of decision trees, which were spoke before, and final outcome based on the most common result from one of those trees for classification tasks, or the average prediction from the trees for regression tasks. It's a method where we use many models together to make better predictions overall. Random forest is great because it helps with the problem of fitting too closely to the training data. It really has a small chance to overfit. So it's because it combining the results of many trees. People like to use random forest because it's actually easy to understand and works very well with different types of data and gives very good results. Now we are going to the dataset review which we used. Actually, to evaluate our methods, we selected the dataset employed in the food demand forecasting challenge, hosted on analytics video. So this data set simulates the scenario where your client is a food delivery company operating across various cities. Within those cities, the company maintains different fulfillment centers to dispatch food order to customers. So the client seeks your assistance in enabling these fulfillment centers to forecast demand for upcoming weeks. This prediction will aid them planning the inventory of raw materials effectively. So here you can see three main sets. The first one contains historical ordered data. Another one contains information about each delivery center, and the last one information about each meal in the menu. Small graphics to make overall look of our dataset. Here we can see many graphics, and from the graphs for the first three, we can see that center type A has a large number of centers and orders, so it's very popular and has a big pipeline of clients and orders. Center type B has a large number of orders, but it's not so much as center C. So you can see also the diagram. that shows that Italian cuisine dominates the rest in terms of the number of orders. Thai and Indian cuisines have similar popularity, and people very rarely chose continental cuisine. Um, so our results of investigation. We evaluated each of the methods using two metrics to choose the best one for prediction demand for food delivery. They are MSE is using mean square error and R squared as evaluating metrics is the lead approach for analysis methods. So for mean square error is a widely used metric in machine learning because it provides a clear measure of how well the models predicts match the actual values. And the R-square is a statistic measure that quantifies the proportion of variance in the dependent variable for the demand, for example, that is explained by the independent variables, which used to predict food delivery. So actual result of each method. So here we can see that linear regression performed the best in terms of MSE, while random forest outperformed other methods significantly in the terms of squared. So in summary, the study outcome suggests that linear regression is suitable for a scenario with similar, more linear relationships between variables, leading to better MSE results. Conversely, random forest ability to handle complex and nonlinear data makes it highly effective in explaining variables and achieving high R-square values. So depending on the specific requirements and the characteristic of the dataset, we can choose linear regression or random forest for our case food delivery service. But in real world, I think mostly will be choose random forest because we have many variables that are not linear, and we need to perform in a world with many variables. So thank you for your attention.